Good morning and welcome to the Driller Newscast, a weekly update on the news and stories impacting the construction, geothermal, and water drilling industry. I'm your host, Brock Yordy, and episode 116 is brought to you by Derek's Drills. Decades of experience and dedication for innovation has made Derek's one of the fastest growing drill rig manufacturers in Canada. The Imagineer behind the best domestic dual rotary drilling rig now offers drills to meet every need of the serious water well, geothermal, and RC exploration driller. Thank you, Derek and Team Derek's, for supporting the newscast. And if you haven't interacted with Derek at a show or online, you should. Great innovator, always solving problems, but he also has a great sense of humor. And today's July 1st, and it's Canada Day. And of course, Derek's sponsors the newscast on Canada Day. Happy Canada Day, all our Canadian drillers. Oh, come on, U.S. drillers. July 1st, 1867, the colonies of Canada, divided into Ontario and Quebec, Nova Scotia and New Brunswick, became the country of Canada through the British Empire, recognizing it. Very cool. Happy Canada Day. I hope you enjoy yourself. Of course, this Thursday, 1776, it's our 4th of July Independence Day. We're going to be celebrating this week too. Because it's a short week, we're going to have a feature with Jay Egg that talks about thermal energy networks and the interconnection between water conservation, energy conservation, ground source geothermal, waste heat, and the importance of thermal networks throughout the country, not just in heating dominance. But before we jump to this great feature, let's talk some safety. All right, this week's safety topic is very direct and to the point. We got a very compacted week, and I know we have lots of drilling projects, and I'm seeing on Facebook and social media, drilling through the weekends, trying to make it everywhere. We're going to have overstressed lake cottages with jet pumps in the basement going out. We're going to have service work due to all these crazy storms and heat, livestock drinking more. And then we have our day-to-day work. And the construction industry, we talk about this often. It's right around 8 million people. There's 166 million Americans that work every day. Therefore, a lot of folks are taking this week for the Independence Day, for Canada Day, and we're going to have lots of distractions on the road. We're going to have holiday traffic. We're going to have our people wanting to be barbecuing and golfing and on the boat as much as possible. And there's a good possibility that you got to work today, Monday and Tuesday, maybe a half a day on Wednesday, and you're just taking the 4th and you're coming back on Friday. What is that doing to our people? What reprieve do they need? What reset? Are they going to burn the candle at both ends? It's right now is the time to start recognizing our risks, the projects that are priorities, the projects that can wait till July 8th, understanding that between the fireworks, late nights, the traffic, the extreme heat, and hard work we've just had in the month of June, we need to make sure our people are good. And those that are going to work overtime and do our service jobs, that they got all the tools and necessary things they need for heading out to an irrigation well or a livestock well. And we got a person working alone. We need a buddy system. We need to understand what our lone worker policy is. We need to be thinking about heat exhaustion. We need to start thinking about, we just spent Tuesday night, Wednesday night this week out late with fireworks, and then we're back at the shop at 7 a.m. What celebrating did we do? Are we dehydrated? Do we need more water? It's a lot, company owners and supervisors, that we need to think about as our people are physically on site and mentally blowing things up and thinking about all the great steaks they're throwing on the grill and having a great Independence Day. So I challenge you. What's necessary work this week? What distractions can happen? Lots of injuries happen leading into this Independence Day holiday. And we need to mitigate those risks and protect our people. Go out, be safe. This week's feature, I have one of the industry's gurus, knowledge shares, continues to help influence and drive our industry to the next level. That's Jay Egg with Egg Geo. And I'm going to let Jay introduce himself. But I just have to tell you that it is an insane treat to have him on. And go check out his LinkedIn and all that's happening, his articles, because there's so much here as we look at ground source geothermal and we look at network geothermals, or we look at this as a whole. We're just seeing this much of it when there's so much more. And we're going to talk a little bit about water conservation today and geothermal. Jay, go ahead and introduce yourself.
You bet, Brock. I have to throw one back at you before I do that, because you reached out to me well before COVID and everything. And oh my goodness, you've turned the drilling world upside down with you're a man after my own heart. And you have really selflessly gone into the industry and made a huge difference. So it is indeed a privilege to be on your program again. And as for myself, I've been in this business for 35 years. I started Egg Geo just before 1990. Before that, I was a nuclear power engineer for the U.S. Navy, and really started the consulting gig around 2012. And that's where we really started working in New York, and New York, as most people know, in the Northeast has the biggest influence nationally for implementation of geothermal systems and thermal energy networks. So that kind of brings us, we still operate out of our offices in St. Petersburg, Florida, but we have employees all over the world now, scientists, engineers, and folks that we need to help do these studies and help implement these systems throughout the world.
So let's jump into it. You know, one of the very first newscasts you came on and you talked about thermal energy networks and where we could go. And that was over 100 episodes ago. And so here we are, and we just saw Framingham come online as a thermal energy network, and we see these in Canada and around the world. And it's hot right now. Man, is it hot. And it's the 3 weeks, and we see this heat dome in Mexico, and we see the temperatures across Florida, and it's dangerous hot. And we get into cooling and these chilling towers. And it hit me as we're pulling water away from livestock right now to make sure communities have enough water. And we're seeing all these other water conservation efforts. You know, I went, how much could a cooling tower consume in a day? And the first thing that comes up is one of your articles. Tell us about it.
You bet. And so I'm gonna reinforce, I just saw a news bite this morning. I live in Phoenix. We have sustained 3 days of the highest daily lows in the history of Arizona. It has not gotten below 91 degrees at night for 3 days. The 110s and 115s are all over. It is like a Martian landscape out there. And so you're exactly right. We are hot and getting hotter. And every degree we tick up in temperature exponentiates the amount of water being used by cooling towers. And it's important for our listeners to understand a cooling tower is usually part of a large commercial HVAC system. And the reason they're there, any building can do a straight air-cooled condenser, but it really increases the energy uptake or reduces it if you do it evaporatively, because just like if spraying a misting bottle on you in the hot sun, it cools you off. That's the same thing with our air conditioning systems. So they realized that more than 100 years ago and started really just dousing the coils outside through spray nozzles in what's called cooling towers to drop the condensing temperature for those chillers and heat pump systems. And what that does is it saves as much as 25% or more on their electric bill. So it's no doubt it's a great technology. The problem is what people don't realize is that other than agriculture, cooling towers are the #2 user of fresh water in the United States. As a matter of fact, when I looked at this based on the 2010 census, I haven't done one for the 2020 census yet, but it was estimated by the Department of Energy that cooling towers in the United States use more than 2 trillion gallons of fresh water a year, and that is more than goes over the Niagara Falls in a half a year. In other words, it's more than half of the. That is phenomenal, and that is a lot of fresh water we could be using for something else. But it's like we're stuck between a rock and a hard place. People say, well, if we take our cooling towers out, then we're going to have much bigger cooling plants and use much more electricity. And the Southern Nevada Water Authority said, we don't care. And they got a law passed that made cooling towers illegal. So all they can do is dry coolers now. So my point is, in writing the article you talked about, was to say, and this is something we've been doing in Florida for decades, if you go along the coast of Florida, you'll notice a lot of the high-rise condominiums and resorts, they don't have cooling towers on the roof. As a matter of fact, they don't have anything outside, and that's because that's where we cut our teeth. We started taking the cooling towers off of the roof and using the aquifer under Florida for the heat sink. And so all the heat from the chillers and the heat pumps in the summer gets injected in the aquifer. And every aquifer is different, but the aquifer in Florida, as you well know, it's called the Floridan. There's others, but the Floridan is 3 states in breadth, and it's an average of 1,000 feet deep from top to bottom. So if you do a thermal analysis on it, we could dump all the heat times 10 that we have in those 3 states into that aquifer, and it would barely even affect the aquifer thermally. And we're getting rid of all that water consumption. And I'm going to go one more point, and this will help bring it home. When I first started studying this type of thing where, okay, you're looking at the OPEX and CAPEX to convert a resort or a hotel or a school to geothermal. It used to be back in 1990, 2000, the energy savings were the overriding ROI factor. Not so anymore. When you look at the cost of water now, it's gone up so much. The water savings becomes the biggest factor in ROI now. While the energy savings are still equally impressive, that water is getting really expensive, and for a good reason. We need to conserve it.
Absolutely. And, as you speak of Florida, we look at California, Texas, Florida. Those are our 3 biggest water stress states, along with being the most House seats, from a political standpoint. And water is absolutely precious, and they're growing states, especially Texas and Florida, as we look at, the upper Floridian to the lower Floridian, and the amount of water that is needed now, just as you get into central and you get into lower tip. We have to have better water conservation, solutions. And this isn't even about extreme weather, or we are seeing the results from the heat. They're saying the Atlantic along Florida right now is at its temperature it should be for August, already in June.
Oh yeah, that's another thing. Boy, we're spinning some hurricanes out of that hot water already, aren't we?
We are. And so it is critical that we conserve this water. So if we take this idea and we expand it into opportunity for thermal networks, how much bigger of an impact could we have?
Well, that is such a great question, because much like and I'll just articulate for anybody that may be hearing thermal networks for the first time. A thermal network is a brilliant utility level geothermal infrastructure. What it does is where each building has to normally, if it's going to be geothermal, have their own set of wells, whether they're closed loop or open loop or whatever. It takes that out of the responsibility of the of that particular building owner or homeowner. Instead, kind of like I always like to equate it to a potable water line. You know, if we didn't have municipal water supply, every single building would have to drill their own water well, and that's just nonsense, right? That's why we have municipal. And so the same thing is true with geothermal. And what that does is it takes all the difficulty of trying to eliminate a cooling tower off of a building and puts it on the municipality. And then the municipality, and that's what's really cool, not only can they utilize surface water and aquifer-based technologies, but they can something that an individual building can't do. If it's a city-based immuni type thing, they can go to their local wastewater treatment plant and think about it. Every bit of water we flush down the drain goes to that wastewater treatment plant, and that's all energy carrying infrastructure. So they could, on a thermal energy network, sink all that energy into that wastewater effluent that's either being injected into an ASR well, dumped into a river, and I mean dumped friendly because we know effluent is typically cleaner than the river itself, or wherever or watering crops. It could all be run through that and get all that heat sink capability from that water, where a single building owner can't do that. That's so difficult and so costly. So thermal energy networks, I think, and I think you probably do too, are the key to really helping to begin to eliminate cooling towers. And if we did an argument for our senators and other legislators, we could say, you want to save water? Forget about everything else. Thermal energy networks are your best bet, at least from the mechanical world.
If I can bring this back and simplify one thing, as you being a guru, and we still hear often in this industry, I just got this message not too long ago that went, Brock, it's great that you're talking about thermal energy networks and geothermal, but that's good for heating dominant states.
Mm-hmm.
Are we still that way with all of the technology and progression we've made?
Not at all. It is truly changed. The cooling dominant states are primarily because of water savings. Like I said about Florida, the same is true in Texas, and of course in Southern California and Arizona. As a matter of fact, I just want to answer your question unequivocally. It's a water savings thing. That is the number one ROI factor now in water stressed areas. I just was invited. I live in Phoenix now. It's a family thing. It's not because our business is here or anything. But as a result, I get a lot of invitations to speak right here in the state. And ASPE has something coming up in September for me. And the funny thing was, the guy who invited me to do it, he goes, geothermal's not really got a lot of traction here. What are you going to tell us about that's going to do us any good? I said, water savings, of course. And he goes, how does that work? And that's just an indication that people don't realize, yeah, it reduces energy networks, and geothermal reduce, they decarbonize and reduce emissions in the north. In the south, they're a water savings mechanism. That's really the biggest part of it. So anywhere where you have cooling dominance, you're going to save a lot of, I haven't even done the calculations on what the potential is other than that one pictogram I did from some odd years ago, where I came up with I worked with the DOE. It's not all me. Came up to 2 trillion gallons of water a year just from converting cooling towers to geothermal. It's a lot of water.
So we in the water industry, everything's referred to in an acre foot.
Okay. Yep.
One acre foot is 326,000 gallons. So that
Okay.
really is 325, 800. But California, Nevada, and Arizona,
Uh-huh.
due to the Colorado Compact and
Mhm.
groundwater and everything we're supposed to do, we're asked to reduce by 3 to 4 million acre feet, you know, off the system. And so you start thinking about 1 acre foot, and you had that really good piece in there. It was like a high school of 700 students uses 30,000 gallons a day.
Yep.
So all 10 days, almost 11 days of school
Yep.
would be 1 acre foot of
Of
water.
water.
And
Yep.
you think about school districts across, even if we went that way, how quickly this is savings that right now we're trying to do through industry and zero discharge and not watering football fields, converting to turf, all of these pieces. And here we have this stuff just going away into the atmosphere.
It's so true. It is such a simple, it is so out of sight, out of mind because people don't think about that. But yeah, and I have it right in front of me. This is a slide, and I'll just reiterate it so the folks that are listening know you're not just blowing smoke. This is from the Southwest Florida Water Management District. They said in an average 250-ton elementary school that the school will use 14,400 gallons of potable water a day for cooling operations. That's enough to fill a good sized backyard swimming pool every day, just from a small elementary. And we know, and you get to the high schools and the colleges and the government buildings and forget about it. And they really are drinking the Kool-Aid, by the way, Brock, where our home office is in Florida. Every high school, elementary school, government building, they're drinking the Kool-Aid. They do them all geothermal now. It saves them cooling tower maintenance. It saves them chemicals. It saves them noise outside. There's no downside to the thing except you got to do it first. You got to do it the first time. Get a driller out there, drill some aquifer exchange wells, do the study, and you're done with cooling towers for the rest of your life.
It's so important. And that, schools and community millages and all of that, we have a big voice there as everybody listening to the newscast, to the drilling industry, to the engineering industry. This is as local as we can get on having a degree of influence. And then you add in the IRA, and
Mhm.
there's not been a better time.
You got a really good point there. It wasn't even going there, but if you take an existing school, building, whatever, and it's got a cooling tower, you can literally take the same equipment that's already cooling the building that's connected to the cooling tower, tee it off, and tie into your new aquifer wells or your new geothermal field or whatever. The bottom line is that that everything you do under those circumstances is subject now to the ITC and the IRA, and can get up to 30, 40, 50%, depending on the way you do it, of all the drilling costs, the excavation costs. And now you have a building that's not using cooling towers anymore. And so never a better time to do it. I mean, it's subsidized to the greatest degree it probably ever will be right now.
And that's 100% to conserve water and get the massive impact of rolling brownouts off our grid.
Yeah.
And they're hand in hand. When we go back to energy production requires water,
Yes.
so it's a full circle when it comes to what we can do with geothermal right now to help our energy grid, fight climate change, and conserve water.
Water energy nexus. It's inseparable, isn't it? Water and energy go hand in hand. And we have so many silos still in the country, like the water department doesn't want to talk about using their water to help cool and heat buildings when they do go hand in hand. we're having that trouble still in the US. It won't be for much longer. Heck, we've gotten a lot of laws passed in the last few years, haven't we? All we got to do is get those silos to start communicating, and we can actually, we talked about it earlier before we got on for this interview, but the greatest thermal energy network available right now is already in the ground, and that's our city water lines. Though we have water moving through there that can give up heat and take in heat and just transport it from building to building. It has to be well engineered because we don't want another Flint, Michigan, and that's what everybody's scared of. But for Pete's sake, we've been using water for refrigeration. Think about cooling towers. I mean, not cooling towers, drinking fountains. They use water in refrigeration, but even better, ice machines. They are a water refrigerant exchange. And what happens is the water departments tend to get, oh no, we don't want any to exchange with any refrigeration process in case something leaks. And it's just an education thing. We'll get through it.
Well, I appreciate your time today, Jay. Any last parting words of what do you got exciting going on right now?
We have so many. Let me just say, I was on a meeting this morning in New York, and another village was meeting with NYSERDA that wants to do a thermal energy network. They're lining up for them now. It used to be like they'd go, I don't know about this. And now they're going, what can we do to get on a thermal energy network as soon as possible? Can it be done by the end of the year? That kind of thing. But what I'm here to say is it's because of Framingham and because of that publicity and the great work of the folks at Heat, Zainab and Audrey and the whole team, thermal energy networks are now, like, I just saw a headline about it that said the people that are on that Framingham network feel like they won the lottery because they have so many things and so many good benefits coming from it. And over the next 20 years, we're going to see a lot of these go in. So I'm excited about it. We've barely begun to see the benefits of these systems, though. I think we're going to find out they're a lot more beneficial than we even know.
I couldn't agree more. And I think the folks in Framingham, and as we look at other communities with chilling towers, rolling blackouts, like this extreme heat, it's going to save lives by having a firm, consistent system and give air conditioning or reliable heating to some people that just didn't have it. And I think that's a big piece we don't think about. And you start looking at our bigger inner city areas that we have Justice 40 stuff going on with. And it's not natural for us to go from, 75 high days and 60 to 64. You started your conversation with, the lows 91. I think what we don't think about in the Midwest and the East Coast is we still open our windows at night and the entire building gets a reset. But when it's 91, the building, you don't get a reprieve. And then it's just a constant heat sink. And this is a big thing just to humanity right now.
It is. Well said. Thank you, Brock, for another wonderful interview. I always love coming on with you.
Thanks, Jay. Thank you, Jay Egg. That was amazing. I want you to think about the synergy there is in water and wastewater and energy consumption and heating and cooling and how it's all interconnected. This is very important for us to think about and utilize. We're going to continue these conversations on thermal energy networks next week. Happy Canada Day. Thank you, Derek's, for supporting the news. Happy 4th of July, everybody. It's a big, fun holiday week, but we do have distractions and we do have traffic and we do have jobs that we're obligated to get finished. I know we have a big book of business right now, more water wells than we could ever drill. We're going to have lake cottages that are overstressed and service calls coming in, not to mention our livestock and irrigation when those things go down. So we have service and all those pieces that are still going to happen, along with our people wanting to enjoy time with their family and celebrate our independence. Check out thedriller.com. We'll have another great newscast on July 8th. Go out, be safe, Happy 4th of July. Happy Canada Day. Thanks, everybody.